Okay, good evening everyone. Today's session we are going to talk about vRealize automation. In our previous session, we discussed during the vRealize automation session 1, I given a complete overview of vRealize automation. But today's session we are going to do the VRA deployment in our home lab. Okay, and vRealize automation it started with few versions, but in the current latest version is 8.7 is available, but the publicly there is no download option from VMware website. So that is the reason for today's session I'm using a N-1 version, older version 8.6.2. 8.7 released this month only, just a few days ago, and publicly they will release the ISO files maybe soon. Okay, but at present there is no binary files from the VMware website to download the latest 8.7. That is the reason I will show you on the 8.6.2 version. This is also latest one. And today we are going to cover the vRealize architecture, some more quickly recall the VRA architecture, and I will show you the standard deployment. Okay, and let's see the our agenda for today's session. And organization IT infrastructure sizes. We'll quickly observe what is IT infrastructure sizes and IT infrastructure most common challenges and what is the solution, recommended solution. And the recommended solution will be vRealize automation. So sorry for the typo here, it is vRealize automation. So vRealize automation, in short form we call it as VRA. So VRA, we can observe the VRA overview, and vRealize installation procedure. So how we can install the vRealize automation, and vRealize architecture. We will talk about vRealize architecture. We have two types of architecture, standard architecture and clustered architecture. Both architectures we can verify. But in our lab, we are going to do only a standard architecture. And VRA components, what is the key components in our vRealize automation, and what is the real-time scenario, what is the usage model. So once the usage model is understand, we can start with a deployment in our home lab. But before we start our all following slides, I'll quickly log into our vCenter and I will show you just to capture a few screenshots. I already tested in our lab before we start the session. I will just show you how it is looks like. Let's say I just log into the our vCenter server. In our vCenter server, we have a two clusters I created. See, one cluster is nested cluster. Nested cluster means ESX1, ESX2, ESX3 are actually technically it is a virtual machines only. It's not a physical boxes. That is called nested ESX. Even if you open our workstation homepage, see here we have vCenter server and ESX is running here. ESX1, ESX2, ESX3. And if you notice earlier we have a three ESX servers, additional three, ESX4, 5, 6. Those three are running on a another Windows workstation, but that workstation I just cleaned up for our VRA installation procedure because our VRA installation is not supported for a nested environment. It requires a physical ESX host. That means ESX must be run on a bare metal hardware. Then only it will allows you to provision a vRealize automation. So to do the VRA testing only, I removed our Windows machine. On the direct hardware, I installed the ESX. Okay, so this is our Intel NUC 10 model box, and it is running with a 6 CPUs and 64 GB memory. And we already created a VRA infrastructure here. Within the VRA infrastructure, minimally it requires a three virtual machines. One virtual machine is VRLCM. That means vRealize Lifecycle Manager. So first VM, I just make it as 01, and VRA, vRealize Automation 01. And for identification purpose, to maintain all the ID user IDs and groups, we require a VIDM, vRealize Identity Manager. So identity manager 1 VM, automation 1 VM, and lifecycle manager 1 VM. These three, it will come by default when we install a VRA standard deployment. Okay, so to open the console and all, we can use the VRA fully qualified domain name. See, this is LCM. So we can select VRA fully qualified domain name. When you copy this fully qualified domain name and just type in the browser, HTTPS type the fully qualified domain name, it will launch the VRA homepage. See, if you see here, the vRealize automation, the purpose of main vRealize automation is speed up the delivery of infrastructure and application resources through policy-based self-service portal on premises and in the public cloud. So our current version is 8.6.2 version, and this is the build number. Okay. And to log into the page, just click on login and see if it is already logged into the VRA Cloud Services console. This is a quick start wizard. When you want to quick start, just launch the quick start and add our existing VMware products here. That is one option. And the main key option from this console is when we install the VRA in our home lab environment, by default, vRealize automation comes with a few components. See, if you see in this, my services is nothing but it's a VRA default components. One is cloud assembly, code stream, orchestrator, service broker. These four are the main VRA key components. And another component is VRA migration assistant. Migration assistant means the main purpose of migration assistant is if you have a VRA 7 series in your organization, that 7 series version, if you want to migrate it to the latest version, that means upgrading to the latest 8 series, there is no direct in place upgrade. We have to do only in a parallel upgrade only. That migrate during that scenario, we will use VRA migration as assistant tool to convert to upgrade your infrastructure from vRealize Automation 7 to vRealize Automation 8. Okay, so these all the components we are going to learn one by one. But before going to learn all these components, same like our vCenter main concepts are when you go to the menu shortcut, we started learning all the topics one by one. First, we started with host, later VMs and templates, storage. We learned so many sessions, networking also few sessions. So similarly, in our VMware vRealize automation also, the main concept is if you try to understand these main components, even if I open Cloud Assembly, there will be some multiple tabs. So once you are familiar with all your Cloud Assembly tabs, that is only the VRA concept. Okay, so before we go into the deep dive, first I will just quickly remove this infrastructure and we'll start the installation. Okay, because installation may take around 30 to 45 minutes time. So just to save our time, I will quickly remove these virtual machines, 3 virtual machines, and will initiate a lab first. And once the while lab trying to deploying the provision status, during that time we'll discuss about the all the prerequisites and VRA architecture in detail. Okay, so I'm just quickly removing this virtual machine. So while removing, there is no specific sequence. You can just power off the VM and remove from the ESXi host. So go to the VM, right click and shut down guest OS. And same way VRA virtual machine, power, shut down guest OS. And same way LCM, power, shut down guest OS. Actually, initially I tried to deploy the VRA in our nested ESX. It got failed. So then after seeing the VMware official article clearly mentioned that it require a standard, I mean bare metal ESXi host. Okay, it's not supported for a nested ESX environment. Okay, one VM is already power off state. So just right click the VM, delete from disk. And the same way LCM also powered off. Right click the VM, delete from disk. Okay, second VM also deleted, and VRA is also going to power off, or else you can just right click power off. Okay, VRA also power off state, just right click, delete from disk. Okay, so the virtual machines, all the 3 virtual machines are removed. So to install the VRA, first we have to download the binary file from the ISO image file from VMware website. So just type in the Google VRA 8 download. Even if you type VRA download, it will automatically redirect you to the VMware website. So once you launch the VMware website, there we can see what is available downloads. Seems my internet is little slow. Okay. See, now we can see the VMware website and download vRealize automation. Current version it is showing as 8.3. Suppose if you select the drop down menu, you can see the current available versions from 6.2 to 7 series. 7 series already outdated, and within the 8 series also 8.0, 8.1, 2, 3, 4. And the latest version currently it is showing only until the 8.6. Even within the 8.6, there is a some latest patch also released 8.6.2. Okay, and you can download VRA using the first option, go to download, and there is an option to use VRO separately also, vRealize orchestrator. Even orchestrator also default component in VRA, and the VRA also have a, some additional salt stack product also available. Recently VMware acquired this company salt, company name is salt. They make the name as a salt stack. Okay, this is also similar like a orchestrator tool. Okay, this is also available while downloading. So today's session, we are focusing on the VRA 8.6.2. Just click on go to downloads. So just click on downloads. See, when you click on downloads, it is showing 6.2 release notes. See the product binaries. All the necessary downloaders are available here. See, if you see here, there is a three types of downloads available. The first one is we realize Lifecycle Manager 8.6.2 easy installer for VRA 8.6.2 and IDM, Identity Manager. That means if you see the first option ISO file, this ISO file size is approximately 12 GB, 11.81 GB. It's close to 12 GB file. One single ISO, it comes with a three virtual machines, Lifecycle Manager, VRA, and IDM. And if you see the second ISO, it is a 5.68 GB. This is only for the update repository. Update repository means if you already have a VRA infrastructure, that VRA infrastructure, if you plan to do a latest patch from 8 series to 8.6.2 series, during that time you can download the second option. But in our home lab present, we do not have any VRA infrastructure. So relevant downloadable binary file is the first ISO. And how about the last one is VRE 8.6.2 virtual appliance. Even if you want to download separately the only VRE appliance also we can download. So we have a two methods, either download the appliances separately and install, or you can go with a easy installer. Generally the best method is you can use a easy installer ISO. It will help you to save our time. Okay, so I'm just downloading this option. This one is 12 GB. So normally when you start downloading 12 GB, it may take some time. So that is the reason the same download file I downloaded and copied to our softwares and ISO folder. See here I downloaded VRE ISO. The size is approximately 12 GB. Okay, and if you see the VRA ICM installer and the binary build number is 19221.692. That 692 ends with 692 binary number you can find from here. Just click on read more. You can see the binary build number is ends with one's last four digits are 1692. The same one I downloaded here, 1692. Okay, and once it is downloaded, you can just mount your that ISO file to your system. Previously already mounted, I just eject and again go to the softwares and ISO files. If you want to mount that ISO, VRE ISO, just right click the ISO, you can choose mount. When I click on mount, it will automatically mount your system. See, this is the 11.8 GB ISO file. Just open this ISO file. We have a three options. One folder is OVF folder. Within the OVF folder, we have IDM appliance, VRE appliance, and LCM also we have a appliance. So either you can use individually appliance you can install and create a VM. That is one method. And another method is you can use a LCM UI installer method. Normally this is the easy installer. So always prefer to go with a easy installer. Even easy installer also it's supported for three flavors. You can install using a Linux OS or Mac OS, or you can use a Windows OS. Okay, so our laptop currently it's our physical system running with Windows. So we can open Windows 32 folder. These all the binaries. Just look for a where is the installer file, installer.exe. See there is a installer.exe. Okay, so just right click the installer run as administrator, it will start the installation process. Let me minimize all the wizards. Okay, so this is the installation wizard. If you see the name here, we realize easy installer for VRA and IDM. So IDM means identity manager, VRA means we realize automation. So we have two options. The first one is install, second one is migrate. Normally migrate option is for you if you want to change from your 7 series to 8 series. During that time you can use migrate option. But for our scenario, the relevant option is fresh installation. So they clearly mention here we realize easy installer for VRA and IDM is a single pane of glass which enables you to install VRA, vRealize Suite Lifecycle Manager and Identity Manager. So that means it's going to create a three virtual VMs. One VM is for VRA, one VM for Lifecycle Manager, one VM for Identity Manager. So just click on install. See, when you click on install, you can see the installation instructions. See, it is going to install VRA 8.6.2, Lifecycle Manager 8.6.2, and Identity Manager. Identity Manager version is 3.3.6. Okay, and the icon for VRA, this is the icon, and Lifecycle Manager, this is icon, and Identity Manager icon. Okay, and if you see the left side, these are all the options we are going to observe now. Okay, so now click on next. When you click on next, the end user license agreement, you can just accept the end user license agreement and customer experience improvement program. Normally this customer experience improvement program, it's just to give you feedback to the VMware. Okay, you can just uncheck this option. Okay, so now click on next. So when you click on next, it is asking us to provide a appliance deployment target. So this deployment target should be, we are going to deploy on a vCenter server only. So it requires a vCenter server administrator credentials. So our vCenter name, just log into our vCenter. Our vCenter name is vc.demolab.com. So just copy the same name, minimize and just enter here. This is our vCenter name and default HTTPS port is 443 and username we have to provide the our vCenter server login credentials. So it is administrator @vsphere.local. Okay, and enter the administrator password. Okay, so this is the target where we are going to deploy this VRA, LCM and IDM is we are going to deploy on a vCenter level. Now click on next. So certificate warning, just accept. And now it is showing our vCenter location. See vc01demolab.com. We have a data center. Under data center 01, you can create a specific folder or you can choose a default one. Later also you can move it to the specific folder location. So let's select as a discovered virtual machine folder and click on next. When you click on next, it is showing us select a compute resource. The compute resource can be your cluster resources. See the clusters, we have two clusters, production cluster 01 and production nested cluster. Nested cluster means all our ESX are running on a virtual machine. So, but for VRA deployment, as per VMware installation guide, it clearly says that nested is not recommended. So you can select your production cluster because the host is running on a bare metal. Now click on next. Okay, and it is showing the storage location. So currently our ESX804 is we have only one local data store, which is VMFS version 6 and capacity is 337 GB. So I am choosing the same data store and just to save our disk space, I am choosing the disk mode as a thin disk mode. Okay, so now click on next. This is the storage location. Now click on next. And then we have to choose the network configuration. See, before we configuring the network, we have to choose whatever the networks are available in our vCenter level. If I select the drop down menu, currently we have only one VM network. So you can choose VM network. Suppose if you have any dedicated production network, you can also choose the respective port groups here. Okay, and IP assignment can be static IP only. There is no option for a dynamic IP. Only the static IPs are recommended. And subnet mask. In our lab environment, all our IP address is running on a subnet mask 255.255.255.0. This is our common subnet mask for all the systems. And gateway also for common gateway is 192.168.10.1. Okay, and DNS server. DNS server should be our Active Directory server. So IP is 192.168.10.70 and domain name. Our domain name is demolab.com. Okay, so I have given all the information, and finally it is asking for provide NTP server. So NTP server also we can use as a our domain server like 192.168.10.70. Okay, same Active Directory DNS server I'm given as a NTP. Okay, so this is a network configuration details. Now click on next. And it is asking us to configure a password. This password can be for vRelay Suite Lifecycle Manager and also applicable for VRA and IDM. So for all these three virtual machines, we are giving a common password. So common password is, I'm assigning one common password here. Okay, so password already entered and confirm the password. Now click on next. When we click on next, you can see the option configuration for VRA lifecycle manager configuration, and we have to choose the IP address hostname. So for this IP address and hostname, let me minimize here and open our spreadsheet. Let's say in our lab, we have a reserved few IP address for lab purpose. If you see the first IP is 70 to 74, we assigned for a ESXi host 4 IPs, one IP for ID and DNS. Okay, and we assigned 80 for a vCenter server. So what I'm thinking is I'm choosing 81, 82, 83 for our LCM, IDM, and VRA. Okay, so these three VMs I'm going to use now. Okay, LCM will choose 81 and IDM 82 and VRA is 83 IP. Okay, so last octant is 83. And the subnet mask gateway DNS is common for all the VMs. Okay, so 81 will use for LCM. So 192.168.10. I'm giving the 81 IP. Okay, and the host name here we have to choose the host name should be fully qualified host name. So in our spreadsheet, I just choose the name as a same name. We realize lifecycle manager 01. So we'll use the same name. And they mentioned to assign as a fully qualified domain name. So we can enter as a VR LCM 01 dot demolab.com. And also VMware recommend that if you want to assign this fully qualified domain name, we have to create a DNS entry first. So that DNS entry also I created earlier. We'll quickly double check. Log into our Active Directory system. And go to the DNS, start run DNS mgmt.msc. When you log into the DNS, verify the forward lookup zone demolab.com. If you see here, we have Active Directory, our ESX host details, and we also have a IDM IP is created, LCM 81 created, 82 IDM created, and VRE 83. So three IPs are already created. Even in the reverse lookup zone also, when you select reverse lookup zone 80, 81, 82, see three IPs already created. Okay, 81, 82, 83 already created. Okay, so there is no issues on the fully qualified domain name. We are okay to enter these details here. Okay, so because our DNS record is already created. And the data center name, our data center name, I'm choosing the default DC, vCenter name also VC, and increase the size if you even if you want to change the sizes and all, you can choose. And the FIPS mode compliance, the FIPS mode normally will use for a to mainly for inbound and outbound traffic. If you want to analyze inbound and outbound traffic, FIPS mode should be enabled. If you disable, we cannot able to do the traffic analyzation. Okay, so okay, we'll okay to enable this option. So this is the life cycle manager configuration. Now click on next. When you click on next, the second VM is going to configure as IDM, identity manager configuration. See, we have an option to, you can skip this identity manager installation, configure only LCM, and later also you can install separately for IDM. That is also one option is available. And the default, the IDM, this installer is choosing the CPU is 8 CPU and memory is 16 GB and storage is 60 GB storage for this identity manager VM. And we can install a new identity manager now, or if you have any existing identity manager, you can also import that existing IDM here. Okay, so present in our lab there is no existing IDM, we already cleaned up the previous VMs, so we are going to install freshly the IDM. Okay, and IDM VM name also we need to enter here. So IDM VM name will use the same name, VIDM01. So same name I'm entering here, VIDM01. Okay, and IP address, we already selected one IP address is here, 192.168.10.82. Okay, so 82 is our IDM IP address. Let me double check. 82. Okay, correct. Now host name, we have to provide the host name is as a fully qualified domain name, vidm01.demolab.com. Okay, this is a host name. And the default admin, here we have to provide a default administrator, whatever the name is convenience for you, you can choose any name. Let's say for our easy understanding, I'm choosing the name as a VRA admin, just a short VRA admin. The same ID is applicable for IDM, LCM, and also we can use for a VRA. Okay, the default configuration email, so we have to enter some configuration email address. Let's say I'm giving our email address. Okay, and the node size, we have a sizes available same like during the vCenter installation time. We observed there is a multiple sizes like t-shirt sizes. So node size medium, large, large, extra large. So better we can go with a medium. Okay, which is the lowest one. So I'm choosing a medium. And the FIPS mode either on or off, it's fine. And sync the group members to the directory group, just enable this option. Okay, just to integrate with all your Active Directory users and groups. Okay, now click on next. So when you click on next, it is asking for a vRealize automation configuration. Okay, even this vRealize automation VRA configuration also, you if you want to skip, you can skip here, or else you can provision now itself. And when you see the VRA deployment, there is a two types of deployment. The first bullet is it showing as standard deployment, and the second radio button is showing as clustered deployment. The only difference is, if you see here, if I scroll down some more, within a standard deployment, we have only one VRA appliance is going to create. See, only the primary node is creating, and there is no additional options. Suppose if I select as clustered deployment, cluster is nothing but a grouping of multiple nodes. So within a cluster means instead of one single VRA appliance, it is going to configure a multiple VRA appliance. Minimally, it will create a three VRA appliances, VRA1, VRA2, VRA3. Like that, it will create when you select the deployment as a cluster deployment. That is the only the difference. But only the another key difference between standard deployment and cluster is, for your test environment, you can deploy with a standard deployment, and for your production environment, always VMware recommendation is we should go with a clustered deployment. Clustered means by default it will comes with a three VRA appliances. Even if you scroll down, this is the additional options that cluster deployment also require a load balancer. And if you just scroll down, you can see three nodes. See, VRA primary node, VRA secondary node 1, and secondary node 2. That means totally one primary node, two secondary nodes. So total nodes for cluster deployment is three nodes. Okay, and this is the advanced configuration. But suppose if I select as standard deployment, it's only provision the VRA automation properties. If I just scroll down, we can see only the primary node. There is no secondary nodes, and even there is no load balancing functionality also. Okay, but when I select a cluster, you will get a high availability. High availability means in case of one primary node or one secondary node down, there will be no impact. So continuously available your VRA infrastructure and it will also provide a load balancing mechanism. This load balancing, you can configure. VMware officially saying that you can use a load balancer mechanism on NSXT environment, or you can configure on FI load balancer or Citrix NetScaler, any third-party load balancer also you can configure. Okay, so the supported load balancer information we can find from a VMware official installation guide. Suppose in the Google, if you type VRA 8 installation, you'll find the VMware official manual. So using that manual also we can find what is the supported. Let's look for a PDF. Suppose there is one 8.5 installation PDF. Okay, this is the installer guide for 8.5. It's almost same applicable for 8.6 also. For example, if I just scroll down here, you can just look for a load balancer, or else let me search. Yeah, load balancer. I just search with a load. See, it is clearly saying that the load balancer requirements can be, you can use NSX load balancer or FI load balancer, or else you can use Citrix NetScaler load balancer. It seems to be, it is supporting only these three types of load balancer. Suppose your organization is using FI, you can go with FI load balancer. If your organization is using Citrix, you can go with this one, or else the alternatively you can go with a NSX also. Okay, but these all the external devices to configure a load balancer. NSX is like a network virtualization software, and the FI is like a physical FI device. Okay, and Citrix also have a NetScaler is one of the physical device. In that device also you can configure load balancer. Okay, and even we open this document, right? If you see here, we are a system requirement document. It clearly says that, excuse me, VRA 8 doesn't support for nested virtual environment such as ESX and ESX VRA. That means on top of any workstation or ESX, if you create ESX virtual machine, that VM is not supported to install a VRA. So after seeing this point only, I realized, okay, we need a bare metal ESX box. Okay, so this is the point is available in a official VRA guide. Okay, let me close this one. Okay, let's download it. Okay, so now let's back to our installation wizard. When you go to the installation wizard, see the cluster deployment, hope you understand. The installation process same like standard deployment. The only difference is we need to configure load balancer. For load balancer configuration in the real-time scenario, if you have your network administrator, they will also help you to configure on FI level or Citrix NetScaler level or NSX layer. Okay, but if you are familiar with NSX, you can directly log into NSX console and create one load balancer IP address for VRA. Okay, in our later classes, if you're interested, I will show you the NSX layer, how to configure load balancer. But for the today's session, instead of cluster deployment, we are going with a standard deployment. Okay, but standard deployment, we can enter all the details. See, VRA environment name. If you want to choose any environment name, you can choose, or we can use a same name like a virtual machine name, VRA 01. Any name we can choose for a environment, and we have to enter the license key. Okay, we'll go with evaluation and the FIPS mode, and the FIPS mode also either you can on or off, that's not an issue. Okay, and the node size, we have a two sizes only here, medium and extra large. So I'm choosing the minimum size. And we release automation primary node details. Primary node details means we have to provide virtual machine name, IP address, and fully qualified host name. See, virtual machine name I'm giving as a VRA01, and IP address 192.168.10. We already reserved the IP address is 83. Okay, and the host name the same as VM name, VRA01.demolab.com. Okay, so even if you want to enter the lowercase VRA01, let me see our spreadsheet again. Yeah, we use the same name, VRA01. Okay, and advanced configuration for VRA here. in our previous VRA 7 series, all our VRA 7 series require a Windows virtual machines also. But when comes to VRA 8, the complete architecture is changed to the Kubernetes architecture. So within the Kubernetes architecture, all our VRA services running on a pods only. So internal pods and services configuration. Default VMware itself recommending K8 means it's nothing but a Kubernetes short form. So Kubernetes cluster IP range is default they given one IP range, and the services also they given one IP range. So better to leave it as a default option. So no need to modify here. And now click on next. So if you see the all the steps here, finally we given the end user license agreement, appliance target is vCenter, and we selected the data center location and compute source as cluster, storage also local data store. We provided the network configuration, password, and the three LCM, IDM, and VRA. This three VM configuration we already given. So once I click on next and click on finish, it will start deploying all these three VMs. So it may take a roughly 30 to 45 minutes time. Okay. So now click on next. See, when I click on next, if it is showing us some red color error message, so we have to enter the license key. Let me look for a license key and enter here. So before entering the license key, let me move the screen to the other side. Let me stop the sharing for a while. I'm just looking for a license key. Any evaluation key is available or not? I just entered the evaluation key. Okay. See, I just entered the evaluation key. Okay, so finally we are at the summary tab. See, it is showing all the summary details, infrastructure information and network details and LCM details, all the information. Finally, just click on submit button. So when we click on submit button, the installation will start automatically. Okay, so during the installation, see first it will install the LCM and then it will move the binaries to initiate and install the IDM and VRA. And finally, it will complete the VRA installation. So it may take some time. So during this time, now we can go back to our slide and we'll quickly discuss the all the VRA use cases and what is the information about the vRealize automation. Okay, so the first point will start with organization IT infrastructure sizes. So normally every organization have a different sizes of architectures, infrastructure sizes. So depends on their infrastructure size. For example, I took this table reference from during our recent, if you remember, during our vCenter server installation, there is a default sizes recommendation for VRA appliance. Even during vCenter installation time, it is showing the tiny, small, medium, large, and X large. So same way, I just took as a infrastructure size example. Even organization infrastructure size, some organizations are tiny. That means very small organization. It may have minimally 10 ESXi host and 100 virtual machines. And a small organization have 100 ESXi host and 1000 virtual machines. And medium organizations are like a count will be increased to 400 and 4000 VMs, and large means again the ESX host count is increased to 1000 and the virtual machine count is 10,000. So large organization means approximately it's running with 10,000 virtual machines. And X large means extra large. So extra large ESX hosts are 2000 and virtual machine count is 35,000. So if you imagine the X large, how many manpower is needed to maintain all these ESX and virtual machine? So it will be a very huge task to maintain all the 2000 ESX hosts and 35,000 virtual machine. So manpower is we require a multiple manpower. Even if you consider roughly 100 or 500 is one resource, even to maintain the 2000 ESX hosts, so much manpower is needed. Even this manpower not only for vSphere infrastructure, we also need a manpower for network architecture to maintain the storage, to maintain the data center operations, tech support. There are so many team members are needed for a large and X large organization. So similar case applicable for tiny, small and medium, but only thing is manpower is very less manpower in a tiny and small, and medium, large and X large, the manpower based on the infrastructure size, our manpower will be increased. Normally, roughly how the infrastructure managers will consider is if you have a 100 ESX host, that means roughly we need a minimally two resource. That means two vSphere administrators is needed. One administrator can be able to manage 50 ESXi hosts and another administrator for remaining 50. So roughly 100 means we require a two resources. So 400 ESXi host means so you can multiply 4 into 2, minimally 8 members are needed to maintain the virtual infrastructure. Because we are not only managing the ESX host, we are also managing the virtual machines as well. Okay. I give an example, but some companies they may use a different strategy to get to recruit the resources for to manage our vSphere infrastructure. Okay, and similarly, data center infrastructure component size will be increased depends on IT infrastructure size. So if your infrastructure size is increased, similarly network devices, switches, routers, firewall, load balancers, and also other network device also it will increase. But I give an example for vSphere infrastructure and storage devices also like sandboxes, storage arrays, and backup appliances. Even we also need to take all our virtual machine backup. To store all our virtual machine backup data, we require a backup appliance along with storage arrays. And also we need other devices like tape library and any of the external storage boxes. These all comes under the storage devices. And also we also require additional like power equipment, UPS devices, power supply, transformers, ACs, even for cooling purposes, we require ACs and data center space and so on. These are all the commonly required when your organization size is increased. Not only the vSphere components, we should also consider about other correlated components. Okay, this is the overview of organization infrastructure sizes. Now we'll talk about based on our infrastructure size, what is our main challenges? See, let's come to the IT infrastructure challenges. Even not only limited to these challenges, I just highlighted few challenges here. The first point is manual process causing high OPEX. In our previous session, we talked about VMware converter. During the VMware converter, it will help us to reduce the high capex. We can able to reduce capex. Capex means capital expenditure. That means the infrastructure initial investment on the physical server, that cost will be reduced. But when you do a IT infrastructure challenges, let's say your organization is let's talk about the medium organization. We have a 4,000 virtual machine. To maintain all the 4,000 virtual machine, you obviously your operation expenditure cost is very high. Suppose every month Microsoft releasing the patches, and similarly randomly Linux also, Red Hat also release a patches. Let's say you have a 4,000 VMs mixed of Windows flavor and Linux flavor. In order to do the patching for 4,000 VMs, can you imagine how many team members are needed? And also we need the operation expenditure. Even if you are recruiting some resource means we need to pay not only the manpower bill, even the servers maintenance. And if you are taking some downtime from the customer, that downtime also consider as a operation expenditure. So like this, there will be some dependencies on the applications. So much is we need to invest if your infrastructure is high and if you are doing a manual process of tasks for patching, updates, any kind of installation. And another point, manual process causing provisioning delay. Even if you are trying to deploy a virtual machine, let's say 4,000 VMs, the same scenario of medium organization, 4,000 VMs. During the initial stage, if you want to deploy a 4,000 virtual machine, normally in our vSphere infrastructure, we know the concept of template. Using the template, you can prepare a multiple templates, depends on your organization flavors. Let's say your organization using three flavors: one Windows flavor, Linux flavor, and Solaris flavor. So based on your organization infrastructure flavor, we already created three master templates: one Windows template, one Solaris template, one Red Hat template. Using these three templates, we can able to deploy the 4,000 virtual machines easily. That is our vSphere administrator job. Okay, now we already deployed a 4,000 virtual machine. How about the assigning the IP address? So our template will help you to deploy the VM only. So it will help you to automate the OS installation time and OS hardening time. These and all it is automated through template. But how about the additional virtual machine components? Additional virtual machine objects or components are: virtual machine is required to be assigned a IP address, and there will be some firewall rules, and there will be some additional packages like antivirus software, backup agent software, vulnerability scanning, and also some project related application. These and all will not comes in a template. We have to again need to be configured separately. So during this time, the manual process of causing a provisioning delay. Even if you want to deliver 100 virtual machine to customer, not only VM provisioning will be faster, but how about the network assignment, installing the some additional software packages? Again, it will take some time, and we need to coordinate with a storage team, we need to coordinate with the network team, we need to coordinate with security team. So multiple teams are involved. When the multiple teams are involved, the provisioning will be delayed. Provisioning is nothing but we are going to offer the complete virtual machine package. The virtual machine should run with a OS application and also the all project related standard softwares like a backup agent and also the vulnerability scanning agent and antivirus software. These are all common for every virtual machine. Even those also sometimes we can maintain in a template and we can deploy automatically. But only thing is once the provisioning is completed, we have to mount it again manually. Suppose our virtual machine antivirus client need to be verify that whether it is correctly pointed to antivirus console or not. These all the some additional task, it will causes the provisioning delay. And some customers they may ask you to, we require few virtual machines ASAP. ASAP means as soon as possible. For new pilot test, there is one scenario is pilot test and one scenario is VMS. VMS means it's not virtual machines. VMS means vulnerability management system. Suppose they want to do some vulnerability scanning. For the vulnerability scanning, they want to need a few virtual machines immediately. And also there is a new project for the customer. For the new project also, they need a few virtual machines immediately. So during this scenario, based on our existing manual process, normally it will take some time. Even though we have a master template, there is some additional components we have to configure like network settings, firewall settings, and also backup settings. These all need to be configured additionally. And those additional challenges I highlighted here. The one challenge is got a request from AppStream. So we got a request from AppStream. Let's say AppStream is requested to provision a 10 virtual machine. But as a VMware administrator, we know how to create a 10 virtual machines using template. But in the office environment, it's not our decision. Whenever the any AppStream requested a email or if they requested a service request using a ServiceNow or Remedy ticketing tool, when they request for a 10 virtual machine, we are not authorized to create immediately. We need to verify that whether this request is approved by the your team lead and management team. Most of the time managers will approve all the requests. When the request is approved, then only VMware administrator will start provisioning those requested 10 virtual machines. So we need to wait for some time whether the request is approved or not. Without approval, we cannot perform any task in a production environment. Remember that. Okay. And how about firewall rules? Let's say we provision a 10 virtual machines. These 10 virtual machines is required to be open here some firewall rules to access our virtual machine access. Suppose on other day we tested VMware workstation installation. To access your VMware workstation or VMware converter, To convert physical machine to virtual, there is some ports need to be open, like 902, 443, 138, 139. If it is Linux machine, we need to add additional port is 22. So these ports are required minimally to convert. Similarly, even for our 10 application virtual machine, each application may require some additional ports. Those ports normally is taken care by networking team. They will help us to open a firewall ports. Even when you send a request, they will not open within a 1 day. It may take some time to open the firewall ports. And also, what are the software packages required? Maybe those new 10 virtual machine customer may require for some additional packages. Those additional software packages are not part of our template. So again, we need to invest some additional time to install those new software packages. And what network should be run? So what network means, this 10 virtual machine you want to point it to a test network or development network, production network, or any other network. We also need those specific network details for each 10 virtual machines. And what are the VM specifications? Like all the 10 virtual machine, what is the size of CPU, memory, disk, and this information also needed. And again, to gather this information also, we need to spend some time to coordinate with the application vendor or application team. And IP address also we needed. All 10 virtual machines should be in a same series or different series. But in our home lab, we are using only the same series 192.168.10. But in the real time scenario, that is not the case. Every network have a different ranges. Let's say test VMs, different network range, production VM, different network range, development VMs in a different network range. Those range information also we need to get it from our networking team. So again, we need to some additional time to work with the networking team. And sometime they may also require some additional network features like NAT, network address translation. So these details also, if customer needed, those information also we need to engage the network team to get the NATing information. And the storage specification. Suppose 10 virtual machine, if you want to deploy from the template, maybe my master template currently running with C drive 100 GB. Suppose the customer after deploying all the 10 virtual machines with the 100 GB disk, customer may ask that my production VMs is not enough with the 100 GB. We need a additional 1 TB D drive with 1 TB disk. So we need to spend again some more time to provision a additional disks. That is the one example. If your data store do not have enough space on your data store, we need to engage our storage team. My data store is already full. Please help to either increase the data store space or provide a new data store for the new project VMs provisioning. So like that, we need to engage the storage team also. And where do we have a capacity? Suppose a customer all of the sudden he asked additional 10 virtual machine. My infrastructure is already fully occupied. My ESX hosts are fully utilizing and there is no enough resources. So we have to do some capacity planning. So that capacity planning also we have to perform as a vSphere administrator. And which data center you want to install, the data center is in a Hyderabad data center or Chennai data center or Bangalore, any remote location data center you want to deploy, that information also we needed. And network zone, which network zone you want to deploy this 10 virtual machine. I'm taking example of 10 VM, the same case applicable for any number of virtual machines. And the network zone can be either intranet network or internet network. Maybe some VMs, they need a intranet. Intranet means it will communicate within your organization. Internet means that VMs can able to communicate to the external websites also. And which cluster you want to deploy. Let's say we also have multiple clusters like management cluster, test cluster, development cluster, production cluster. So whatever the requirement your application owner given, based on the requirement, we need to choose the respective cluster. But in our lab, for testing purpose, we are using all in a one cluster. But in the real time scenario, they will segregate everything in a different clusters, different data centers, and also the network zone also will be different. Okay, and what type of backup is needed for this new VMs? Even within a virtual machine backup, we have a three types of backups. I given one example: VM full image backup. That means all your virtual machine files need to take backup: VMX, VMDK, NVRAM, and log file. Some customers they say, I don't want VM full image backup. I need only guest OS C drive, D drive backup. So they don't need on a VM level backup. They need only on a OS level backup. That is also one scenario. And some users, application users, they recommend that I no need VM backup or OS backup just to save our backup size cost. Or even if you take the full image backup, obviously the cost is high. And if you take the application backup, your file size is only limited to the your application data. So this information also we need to gather from our application team. Uh, Again, here also we need to coordinate with a backup team as well as application team. So all these processes are considered as a additional challenges to our IT infrastructure. I covered most of the common IT infrastructure challenges, and finally require more manpower to perform all these manual changes. Okay, not only in a compute means our vSphere, ESX, and vCenter, and virtual machines. Network means all the network devices like NSX or any physical network switches, routers, firewalls. And storage means they will mainly take care of the storage devices, backup appliances, tape libraries. And security team also they always maintain about the vulnerability scanning, security scanning, antivirus scanning. Those and all taken care by security operations team. And the backup separate team, tech support team. These are all the common teams for IT infrastructure. So I given few examples. Maybe some companies they have a separate different kind of team structure. Like some company within a network team, they maintain a level 1 team, level 2 team, level 3 team. So some company all they maintain as a one common team. Even L1, L2, L3 they make it as one team. Okay, it's a depends on the company organization structure. Okay, so not only these challenges and so on, there are plenty of IT infrastructure challenges. So in order to address all these challenges, VMware recommended best solution is vRealize automation. So recommended solution I given as vRealize automation. So why should we automate everything? So just why we are using vRealize automation, the main purpose is VRA reduces the complexity of provisioning VMs in on-premises, hybrid cloud, and multi-cloud environment. It's not only limited to your on-premises environment. With on-premises means within a data center level, or it will also support for a both private and public. If your organization have private and public, it is considered as hybrid cloud. If you have multiple hybrid cloud plus any additional cloud is considered as a multi-cloud. And VRE enables business relevant self-service portal for IT users. Here, self-service portal is nothing but when user submit one request, VM provision request, he no need to worry about the contacting vSphere team, network team, storage team and all. He will just submit one request using VRA portal. This virtual machine automatically comes with a virtual machine OS, IP address, required storage, and required firewall rules, software packages, everything comes in a one single package, and user will submit only one single request. So we no need to contact network team separately, storage team separately, security team separately. All this process is automated with a one request. Instead of raising multiple requests, within one request, we close the case. Okay, so that means it will help you to every task is automated. And vRealize automation service are running as pods. So VRA service also completely not like a earlier VRA have a Windows virtual machine also. Now architecture is changed. VRA is running in a Kubernetes platform as a pod. If you have a VRA running on a pods means even troubleshooting also pretty simple. Even when pod is down, immediately you can provision a new pod. No need to spend long hours to do the troubleshooting. And VRA help us to reduce the high operational expenditure. If you do not have a VRA, we need to invest on manpower, we need to invest on all the business process and all. But if you have VRA, all the operational expenditure cost will be reduced. And VRA help us to reduce provisioning delay. Even provisioning delay for compute, network, storage, all the provisioning delay will be reduced due to fast provisioning mechanism in VRA. Okay, so I given one example use case here. Suppose servers build average deployment time. If you see the traditional infra means there was no virtual infrastructure during that time. If I'm trying to build a 100 servers means normally it will take months time or years time for 100 physical server deployment. But when comes to virtual infrastructure, one of the most leading provider of virtual infrastructure is VMware vSphere. Using vSphere, we can able to deploy 100 virtual machines within few days. And sometimes maybe to configure some additional settings and all, it may take weeks. But provisioning time is only days or weeks only. But when the count will be sometime it's within a days we can provision. If the virtual machine count is increasing, it may go for weeks only. But compared to traditional, our months become days, years become weeks. When comes to the automation, we realize automation with integrated infrastructure. Using the we realize automation, again the days will become as minutes and weeks become as a hours. So the complete time is reduced. That is the reason I mentioned as VRA help us to reduce provisioning delays due to fast provisioning mechanism. So even in the interviews, they will ask why should we automate everything means you can explain or elaborate these points. Okay. The main purpose is reducing operation expenditure cost, and also the provisioning will be mainly for fast provisioning. Okay. This is the recommended solution for automation. And we'll talk about another point now. See, the another point is here, we realize automation 8.6.2 overview. So this point we covered in our previous session. Let me quickly elaborate. So we realize automation, as I mentioned, you can run directly on a infrastructure as a service platform, software as a service platform, or anything as a service platform. And these all the main VRA components, say cloud assembly, service broker, code stream, and VRO, we realize orchestrator. When you install VRA, these components will come automatically. Once you start learning each component in detail, that is only the VRA concept. Okay, the main key concept for VRA is when you're familiar with all the four components, that is your VRA automation skill. Okay, and the benefit of VRA, you can run on a vSphere platform, VCF private cloud platform, and VMware cloud on AWS hybrid cloud platform, and also you can run on a public clouds, Google Cloud, Amazon Cloud, AWS. Anywhere you can run this tool. We realize automation. It will help you to automate, but end users result is he will just submit based on the menu. He will just submit one request. That request using this automation, it will run automatically, and finally it will deliver to user. So we no need to bother about network storage, all the separate option. That the complete activities is automated using VRA. Okay, the same point I highlighted here. So we realize automation 8.6.2 overview is a modern infrastructure automation platform. It is designed to help organization implement self-service hybrid clouds, multi-cloud automation with governance and DevOps-based infrastructure delivery. Not only the self-service clouds, it will also provide a development and operations-based infrastructure delivery. And besides, VRA increases the productivity and agility through the self-service capabilities and delivers a DevOps-ready automation platform. Okay, so there's some more additional overview points I just highlighted here. Here also, as I mentioned, VRA is like a container based microservices architecture, and it will offer a all simplified management, configuration, and also improved performance and scalability. And VRA, as I mentioned earlier, see VRA 8.6 has been re-architected to support this modern container based architecture. And as a result, VRA 8.6 can scale better and greatly enhance the ability for its customers to deploy and manage multi-cloud environments. Excuse me. Okay, so in our next slide, I'm going to show you the VRE architecture standard deployment. See, in our today's lab, we identified how to install the VRE architecture. Excuse me. See, the standard deployment mainly the proof of concept and mainly for small environment. This deployment includes the three components. See, during the today's installation, we notice the first installation is LCM, and using LCM, it will provision a IDM, identity manager, and then it will provision a VRA. Okay. Even the standard deployment include mainly three appliances, and vRelay suite lifecycle manager deploy first, and then it will deploy the VRA identity manager and automation. Okay, this is the standard deployment. We have only three appliances. Suppose the next architecture is clustered architecture. In our clustered architecture, only difference is VMware at present, they haven't provided clustered architecture for lifecycle manager. Lifecycle manager still we use as a single VM. Okay, maybe in future versions 8.7 or latest version, we don't know how they will design this LCM. But at present, as of today, LCM is supported for only single virtual appliance. There is no load balancing mechanism. But when it comes to IDM and VRA, we have a load balancing mechanism. Load balancing means we must need a three IDM appliances to maintain this LCM load balancing, we need to configure NSX load balancer. This is the icon for NSX load balancer icon. This load balancer is normally we have a load balancer one IP address. Whenever the LCM trying to contact, instead of contacting appliance 1, 2, 3, it will contact the load balancer IP. It will redirect it to the respective appliance wherever the load is free. Okay, all the load will be taken care by load balancer. And same scenario applicable for vRealize automation. Even vRealize automation clustered deployment is nothing but we require a 3 appliances, and to balance the load we require a NSX load balancer, or we can use a Citrix NetScaler, or we can use a FI load balancer. Anything we can use. And this is the same points I highlighted here. The cluster deployment is used in a larger enterprises has the following architecture components. See, it includes one VRLA appliance, one or three IDMs, and three VRA appliances. A load balancer is required for this deployment, and this deployment achieves high availability also. High availability means in case of one IDM is down or one VRA is down, there will be no impact to your production. Okay. And this deployment type is recommended for production environments. Okay, this is the architecture clustered deployment. Now we'll talk about a VRA build procedure. See, if I see the build procedure, so this table I just copied from the VMware installation guide. So if you see the requirements for the CPU, memory, disk requirement for 3 appliances, if you see the LCM, the minimum CPUs are 2 and memory is 6 GB, and hard disk size is minimum required size is 78 GB. And IDM also 8 CPU, 16 GB memory, and 100 GB total disk size. And VRA, we have while deploying, if you notice, we have a 2 types of sizes. Either you can choose t-shirt size medium or extra large profile. If you choose a medium profile, minimum CPUs are 12 and memory is 42 GB and the hard disk size is 246 GB. It's only for single node installation. Suppose extra large profile means 246 GB. It is also the size is for only one node. But if you choose for a cluster deployment means each node is consist of 246 GB of hard disk. It's approximately 250 GB. Okay. And vCPUs are 24 and the RAM size is 96 GB. So why we go for extra large profile is if your organization size is either large organization or extra large organization, during that time, we choose the relevant size of VRA. Okay, and I highlighted one key point here. We realize automation 8 doesn't support a nested virtual environment. That means if you are using a in your home lab, if your ESX is running on virtual machine, we are unable to test the VRA 8 installation. So we must and should install ESX on a bare metal. Then only it support to deploy the VRA 8. And installation procedure, whatever we discussed today, all points I highlighted here. See, let's start with the first point. Download vRealize easy installer ISO. So that is the one we did it today. And we mount the ISO and run the executable. We just mounted the ISO. We double click on the installer. Then it will start installing the lifecycle manager. Once the lifecycle manager is completed, it will start deploy IDM, and then followed by it will install a IDM it will install IDM with LCM, and then it will install a VRA, and finally VRA is installed and all services are up and running. This is the installation procedure. So this is one of the interview questions. Some of the interviews they will ask, can you explain or elaborate the VRA 8 installation procedure? That time you can try to explain all these 6 points. Okay, and the configurations also they may ask what is the sizes available in VRA. So medium profile and extra large profile. Okay, so you will quickly log into our lab system and we'll see what is the status now. See, the installation is still going on. See, if you see the green color light initializing, LCM is installed, moving the binaries to installing the IDM and VRA. So still it is loading. If you see this URL already, LCM is installed. So open our vCenter and we'll see how many VMs are created at present. Oh, it seems to be LCM also provisioned, VRA also provisioned, and IDM also provisioned. Maybe some of the binaries are still pushing. Okay, 3 appliances are created. When you select ESX4 virtual machine tab, see you can see the 3 VMs are already created. IDM, Identity Manager VM, VRA, and LCM. Even you can see the configuration details here. See whatever we discussed, CPU, memory, and disk sizes. Okay. So now Just minimize this and we'll back to our slide. So now, until now, we discussed about the VRA deployment architecture. We discussed about the VRA deployment, standard deployment architecture and cluster deployment architecture. Now I'm going to explain about VRA appliance level architecture. Within the VRA OS, what is the architecture inside? So that architecture I'm trying to explain here, appliance level architecture. So this is very important point. So we realize automation appliance is powered by Photon OS. So Photon is one of the open source. It's developed by the VMware organization. So the version is 3.0. Within this version, they had the native Kubernetes in short form K8s, okay, is installed on the OS host is contained services. So they used this OS. On top of this OS, they make it as a Kubernetes OS, and with this combined package, they make it as a vRealize automation appliance. So when the vRealize automation appliance is deployed, at the first boot, the Docker is installed. Even the Docker also comes with a VRE appliance, and the Kubernetes cluster also configured. And Docker, Kubernetes and all will have a separate session. I will explain in detail during the next following sessions. Okay, just try to understand the terminology in this session, and the in detail concepts I will cover again in the subsequent sessions. And Helm also one of the new terminology. Helm is a package manager for Kubernetes. So Helm packages configure and deploy appliances and services onto the Kubernetes cluster. Okay, earlier we discussed about deployment provisioning time. One key point we discussed, the latest technology Kubernetes and microservices containerization platform, our VRA helps to deploy in a minutes or hours. But when you use a function as a service or Kubernetes infrastructure container platform, our application is able to run on a microservice application. The provisioning time again reduced to minutes and seconds. So that must fast our IT infrastructure is evaluating. Evaluation is going on. Okay, so the same points in the diagram also appliance for when we power on the VRE appliance. So the second one is Kubernetes is installed and configure automatically, and Helm is like a, it's a Kubernetes package manager. This package manager from private registry and deploy the pods. So pods means all our VRE services running as a pod only. Okay, so complete automation is completely simplified as one appliance. Even troubleshooting also very simple. Okay, in our previous version VRA 7, if you want to deploy a VRA, minimally we have to deploy 13 to 14 virtual machines. But now it's completely automated. We have only VRA means for for standard deployment, one appliance, for cluster deployment, three appliance. So our previous VRA 7 series, minimally 14 VMs we need to provision. So the infrastructure is completely simplified, and even troubleshooting also pretty easy. In our previous VRA 7, if you're having any infrastructure layer issues, we have to troubleshoot layer by layer. Okay, but here the troubleshooting is very simple. Even any service down, just redeploy that specific pod. Okay, those troubleshooting and all we'll discuss later. Okay, and now some more in detail. Whatever the point I highlighted here, the same point in the graphical view. The first VMware deployed the Photon operating system. On top of the Photon, they used a Kubernetes platform, because Kubernetes is a open source. Anyone can use to develop the code. So they use the Kubernetes. It is a clustered technology software. Okay, Kubernetes actually developed by the Google. Okay, and using the Kubernetes, there they inside they run a multiple pods. These all the pods, each pod is refers as a one VRA service. Okay, so the seven points I highlighted here. All the core vRealize automation services run as Kubernetes pods. See how many pods we have. Even the pods within the namespace call it as prelude. This is the name, and the namespace are a way to divide Kubernetes cluster resources between multiple users. And a vRealize automation has 16 core container services. 16 means just if you count these pod services, let's say 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 8, so 16 VRA services. All these services is running. So container service with each is having its own web server running on Kubernetes cluster. Okay. So in detail of all these services, we'll discuss in the upcoming classes. Okay. Now, whatever when we install the VRA, we'll see what is the main components are coming. So this one will observe today beginning of the session. See after when we connect to the VRA, homepage. Let's the homepage is same VRA name dot our domain name VRA01 dot demolab.com. When you type the VRA URL, you can able to launch our quick start wizard. Within the quick start wizard, we can see our VRA components. The main key components are service broker, cloud assembly, code stream, and orchestrator. This is the components will come automatically. Okay, so all these components information I highlighted in the following slide. See the again same point. VRA is running on any cloud, private, hybrid, or public cloud. Any cloud you can run. And when you are installing VRA, the main products it will install Lifecycle Manager, Workspace One Access. IDM another name is Workspace One Access, and we also have a main key components: Orchestrator, Service Broker, Cloud Assembly, and Code Stream. So the all the each component I just explained here infrastructure. Instead of reading all these points, just understand that service broker mainly for self-service access. I highlighted here self-service access, and cloud assembly mainly to design our code infrastructure as a code. Normally, infrastructure as a code you can develop using a ML scripts, or you can use any of the Python scripts also you can use to develop the infrastructure as code, or you can use Terraform, you can use Ansible, anything you can use to prepare your infrastructure as a code. And code stream, code, the name itself says code stream. Code stream is mainly for a DevOps functionality. You can use continuous integration, continuous development. These CI CD pipelines you can implement in a code stream. Okay, and orchestrator, the main purpose of orchestrator is for third party integrations. This same the four main whatever the components are available, just for our easy understanding I try to explain a VRA common usage model. If you understand the usage model, it's easy to understand the remaining use cases for all the VRA. Okay, so let me try to explain VRA common usage model. Okay, so this is the diagram. Let's say if you say let's start from the left side to right. VRA common usage model. We know the first box it explains about vSphere. We know vSphere how to create a template for Windows, Linux, and we also provision a OVA. OVA means Open Virtual Appliances. So there is a some manual prepared templates, some are a predefined templates. So anything we can use. And this left on top of vSphere, I given as a, all the components of VRA, service broker, code stream, cloud assembly, and orchestrator. This is the VRA components. Now let's try to understand this concept. For example, we already set up a VRA, everything is ready. So when the VRA is everything ready, what the end user will do is, end user will log into the VRA console. They will do a request, not only one request, they can provide a n number of requests. N number of means multiple 100 requests, 1000 requests also they can submit. But while submitting a request one, there is a some custom form. It's a, like a custom form is nothing but a web form only. When I log into a VRA portal, they will provide a custom form. In that custom form, they will fill all the details. Like suppose they need a one virtual machine provision. So when they provision a one virtual machine, immediately this request will go to the cloud assembly. The cloud assembly, we already prepared a some design here. A design on a cloud assembly. Based on the user request, this virtual machine will go to the cloud assembly. It will check for the whether this request is available in our cloud assembly design. When the respective VM provision design is available, that design immediately it will call the vSphere, and using the vSphere, suppose customer requested for a Windows VM, using our vSphere template, it will provision a Windows VM. This is the first example. Okay, suppose customer is not only request for a simple VM provision, sometime they may also require a some application delivery, any of the request application. Those applications we can application deployment codes we can implement on a code stream. See, I given one example is continuous integration task, or VRO, realize orchestrated task. This here, based on your customer multiple requests, you can implement those CA task here that should be integrated with cloud assembly. Okay, always custom form, it will trigger to the assembly only, it will look for a design, but design must be updated with a respective codes and also respective vRealize orchestrator workflow. And these two are a, I given the first scenario as a VMware VRA automation engineer, we have to do the vSphere environment must update it with latest templates. And the second point is we need to ready with a onboard plans. And the third point is we need to prepare a respective workflows and application delivery. When you're ready with 1, 2, 3, 4, all the settings are ready, then customer end user is nothing but a customer or client. Client will log into VRA portal, they will request a VM provision. When they request VM provision, immediately it will look for a design. Based on our design, it will pick a, suppose customer request for Linux VM. Within our design, it will choose a Linux VM design and it will deploy the virtual machine using the template, it will provision here. That means whatever we are doing in the vSphere manual task, all the manual tasks are automated using VRA. Just for easy understanding, one example is, suppose if you want to prepare a lunch or breakfast in your home, all the items we have to bring and we need to cook ourselves, all the recipes and all we need to mix and we can make our breakfast or lunch or dinner, whatever it is. Suppose the same concept, if you are going to any restaurant, when you go to the restaurant, we no need to think about all the materials, all the recipes and all, we no need to worry. You can just took your menu. Within your menu you can order whatever the item you want. If you go for a dinner time, you can just choose your dinner meals or anything you can choose. So that is nothing but a service broker. This service broker have a, even in the icon itself you can understand there will be a multiple catalog items. So customer can be request any item. When they request this item, normally what it will do nowadays, even in the application also we can order a home delivery also we can order. You can open that any application, food delivery application. When you order for any item, immediately that order number will submit to the cloud assembly. This assembly will choose whatever the request come. This request is for which item, that respective item they will make it. And how they make it is, they will make it in a, based on the recipes they will make it and deliver to the customer. The same scenario, but here it is a technical concept. Normally for virtual machine provision, we know how to create in a vSphere level. But when the virtual machine is provisioned, customer may request you to provision a some additional firewall rules, additional storage, and additional software package installation. This and all we need to spend some additional time. That provisioning time we are automating using VRA. Customer is no need to worry. Even they required for 100 VMs or 1000 VMs, they simply log into the VRA portal. They will submit one single request instead of submitting one separate network request, separate storage request and all the additional burden is gone when you're using a VRA. One simple request, it will start provisioning. VM is ready within a few minutes. But only the difference is, in order to run this automation functionality in the back end, our automation engineer has to perform all this task. We need to make it some ready with a some default menu, like how the hotel management they maintain few menu for breakfast separate menu, and similarly lunchtime separate menu. Same way in our IT services also we have to maintain a separate catalog items. That is the reason in the top I mentioned as this item one for the first request they can submit it by end user only, but for VR engineer we need to come with a reverse engineering. Our we need to start with here to until the top. Okay, once our code stream, cloud assembly, orchestrator, everything is configured, we all this information we need to publish to the service broker. Okay, that's why I mentioned 5 for VRA engineer and one for end user. For end user, they don't know about what we did in the backend, like how you order any item, backend how the chef is cooking and all. We no need to worry. We just worry about whether my dish is ready or not. Same way, even the customer is also look for a whether my virtual machine is created with additional storage, firewall ports, and also additional software packages are ready or not. They will think about only that scenario. But the backend, how we can prepare the automation and all, our VRA administrators core knowledge. So for application automation and all, we'll use code stream. And if you want to install any additional cluster, which zone we need to install, all the conditions and all you can prepare in a orchestrator respective workflow. Suppose the customer submit a request for, I need to create one VM on a production data center and one VM on a test data center. So which data center we need to create, that condition is applied in a workflow layer. Suppose customer is asked for a multiple application. The specific application we need to maintain multiple packages ready in our code stream. Okay, so not only our VRA automation engineer to implement the codes, we need to also engage the development team. Development team will help us to do the some code implementation for applications delivery, and even developers will also help you to prepare a workflows creations. Okay, this is the core concept of vRealize automation common usage model. If you have any questions, let me know. It is completely advanced to our vSphere concept. So that's it for today. I will quickly log into the our vCenter and we'll see the installation status. Let me log into our lab system. So let's open the installation wizard. See, if you see here, installation process is completed. See, when you see the first point, we are SLM. That means we realize suite lifecycle manager services are up, and URL is this is a URL. URL is like a same VM name dot our domain name, and another VM is IDM. IDM means integrated manager deployment is successful, and the URL user interface is this is the URL, and VRA successful URL is this one. Okay, if you want to see quickly, we can just log into three consoles. Just right click here, login. It is loading, and similarly launch the another console also, and similarly launch the VRA console also. So I just try to launch the three consoles. So click on advanced, connect, and this is a lifecycle manager. So lifecycle manager, it's clearly given the ID is admin at the rate local. So you can try to log into the admin at the rate local and enter the password. So this is the lifecycle manager login. So the in detail, all the tabs information I again explain in the following classes. But in this session, our main focus is how to install a VRA. It is a pretty simple to deploy a standard deployment. Only thing is before installation itself, we should be ready with our respect to ESXi host hardware is ready, and we also have enough capacity to provision a three virtual machines. All these configurations we need to validate. Okay, and the lifecycle manager, this is a login. When we log in here, just click on lifecycle operations. So you can see whatever the request we submitted until now, all the information you will find the request status here. And even if you go to the request status, see this is completed, VRA completed, and even the default data center completed. All the information you'll find here. If you want to review what the steps it's done in the backend, in the request status, click on completed tab. You will find, see, in the backend it's done the all the stages from 1 to 12 stages. See, first it's prepare a product prerequisites, and finally it's installing the VRA second stage, and third stage is license. We already assigned one license key, and it is also install a certificate for VRA, one certificate to authorize and initialize the VRA cluster. But in our cluster, we just skip this part. We choose as a single standalone VRA. And the sixth point, it also deployed VRA STDC manager watermark, and some steps are configured on the stage 6 and stage 7. And stage 8, all the backend service, whatever it is running, all information you will find in a stages wise. Okay, that's the reason it took longer time to finish the upgrade installation process. If you see here, some took a stage 5 took 18 minutes, and overall time for the only the VRA is 28 minutes. Okay, and this is the lifecycle manager. Even if you go to the, if you want to create an environment, click on manage environment. You can see within a vRealize lifecycle manager, you can see this is icon for IDM. IDM you can see, and you can see a VRA. So these two are can manage from a LCM console. Okay, and another tab is for IDM. IDM means identity manager. Identity manager mainly to integrate all your users and groups. So here the default admin is we given as VRA admin and assign the password for VRA admin. VRA admin. I think password is something wrong. Let me try admin. Okay, password is admin, login is admin, and the password is common password I given. See, this is the identity manager login. So when you log into identity manager, see you can see the all the users and groups. Present we have two users only. One is admin, another user is VRA admin. Okay, two users are created. Later you can create, you can integrate IDM to our Active Directory also. Okay, this is the IDM console. Now I'm trying to log into the console is VRA console. This is the VRA console. Click on advanced, continue. See vRelays automation. See the even in the home page itself, it's clearly saying that speed up the delivery of infrastructure and application resources through policy based self-service portal. Okay, on premises and in a public cloud. Any environment you can run. And now go to the login page. It is showing the 403 error. That means just to sign out and relogin. Okay, I'm just relogin with VRA admin. So VRA admin somehow it's, let me re-enter the password, or we'll try with admin. Sign out. Okay, so typo, sorry, fat fingers. Okay, now we are able to log into VRA Cloud Services Console. This is a quick start widget. So login ID is same ID only, VRA admin. Okay, and our main service are Cloud Assembly, Service Broker, Code Stream, Orchestrator. So all the tabs I'm not going to discuss today, but quickly show you what is the benefit of each one. Let's say Cloud Assembly, first one. When I see the Cloud Assembly, even how to set up the Cloud Assembly and all, VMware clearly given the guided steps. See cloud template we can prepare, and infrastructure we can prepare, and all the deployments. Deployment not only limited to on premises, you can deploy on a cloud also. Okay. When I click on continue, see in Cloud Assembly tab, there is a guided steps available in the right side, or just close. These and all I will explain in the later classes. But the main concept here is when you go to the connections, when I click on cloud accounts, in the right side, you will find a cloud account section. Here, when you click on add cloud account, you can see what in where you want to run the VRA. It is supported for all these environments. You can run on your AWS. You can add your Google Cloud Platform also. You can add Azure platform. You can add NSXT. That means NSX transformers and NSX vSphere. NSX supported for vSphere. NSXV also you can use. vCenter also we can add, and vCloud Director. vCloud Director is a previous version of VRA, and VMware Cloud Foundation. It is a private cloud, and VMware Cloud on AWS hybrid cloud. So from this widget, we can understand that VRA is compatible to add the cloud accounts of all the private cloud product, hybrid cloud product, and public cloud products. Okay. For example, in our lab, we already have vCenter. Just click on vCenter. You can enter our vCenter server credentials here, and so that it will allow you to add a vCenter information. For example, our vCenter IP address is, or hostname we can give vc01.demolab.com, and the login credentials administrator at the rate vsphere.local, and password. When I enter this one, just click on validate, whether we are able to validate or not. See the certificate warning, just accept. See validation is, credential validation is successful, and the configuration, it is asking us to choose the data center. We have only one data center. If we have any NSX manager, any tags and all, we can choose, or else we can update all these remaining details later also. I'm just adding for our understanding purpose. So like this, not only vCenter, we can add all the remaining cloud accounts also if you have. So that is the reason the first point I highlighted, VRA can be run on any environment, either on a cloud, you can integrate with the cloud, you can integrate with hybrid cloud, which is VMware Cloud on AWS, and private cloud also, VMware Cloud Foundation, or you can use for a on premises. On premises means vCenter server. Okay, this is one option. And even the integration, suppose in the same wizard, if you select the below integration tab, in a click on integration tab, you can also integrate VRA with, there are so many default integrations are available. These are all the VRA use cases. You can integrate Active Directory, you can integrate Red Hat Ansible, Ansible Tower. So many options are available. These and all in detail I will explain in the later classes. Okay. Now again, go back. If you want to go back to previous menu, right side, click on the menu bar, and you can see here identity and access management, our main components, cloud assembly, code stream, orchestrator, service broker. Just now we see the cloud assembly, how it is view. Now we can select a code stream. Suppose if I select the code stream here, the mainly the DevOps kind of thing, all the continuous integration and continuous development platform here. So that is the steps they given clearly. First, add the endpoint, create pipeline, run the pipeline, manage execution, and view the dashboard. This is the steps we have to follow. Okay, and same way, another component of VRA is orchestrator. So select the orchestrator. Within the orchestrator, you can create a multiple workflows. Suppose here, if you see the workflows under the library, some of the default workflows given by the VMware. We no need to think about our own intelligence. VMware itself given us some predefined workflows. Using the existing workflows, we can configure, or you can create the conditions and workflows depends on your customer requirements. Okay, this and all I will explain later classes in detail. Okay, so and even you can use the inventory. Suppose if I select the inventory, our vRelease orchestrator will help you to add it to your application REST APIs, SOAP, and all the configuration. Even just now we added vCenter, right? Our vCenter can be integrated here. Okay, you will see the vCenter plugins. Okay, and also the any of the additional cloud service. See, our VRA is integrated with VRO. Okay, and not only this one, you can integrate PowerShell. There is just so much to learn for the automation platform. Okay, once we are familiar with our existing concept, we'll go with the in detail of VRA concept. Okay, and this is about the one of the component orchestrator. Same way, if you want to choose another component, choose here service broker. Either you can open in a same wizard or just right click here, open a new tab. It will open a separate tab. Right click, open a new tab. So service broker, it's open a new tab. But present catalog items is showing as no items because we haven't presented to the customer. No items are created yet. So our as a VMware administrator, we have to provide a list of catalog items here. Okay, so catalog items, how it looks like is, suppose in the browser, you can just type VRA catalog items. You'll find some sample images. Go to the images tab. Maybe the instead of Google, will better go with the Google browser. Oh, it's loaded. I am just selecting VRA 8 catalog items, how it looks like. Go to the images. See, this is how the catalog items looks like. Suppose I'm opening one image here. Oh, this is not clear. So normally the catalog item consists of multiple requests we can submit, like VM provision. This is how the catalog item is looks like. See, there is a multiple request in the tab, so we can choose like a Linux VM or Windows VM. Anything user can select the request and submit. But this request and all, initially we have to create first, then only we can submit those requests. Okay, and that's it for today. Even if I go back to our slide. So the same thing I just explained. If the users will be, they can see only service broker. The backend part is done by the our VRA automation engineer. Okay. So if you have any questions, let me know. If no questions, we can end the session here. Thanks for your time.
Thank you, sir.
Thank you.
Yeah, thank you. Thanks for your. Bye for now.